Okay, hello everyone. So we are going to apply Cramer's rule right now. We are going to apply what we've learned before, all about converting systems equations to augmented matrix and also determining the determinants of square matrices. Okay, so we will apply this Cramer's rule to an example that we've already done before. This is the first example using matrices. So, and the answers are already here. So let's confirm if what we get using the Cramer's rule is um, the same as the answers that we got before. So it's like a sort of checking using another method. So here is actually the formulas for the Cramer's rule. Here you have it. Okay, these are the formulas. So D here is the determinant of our coefficient matrix. So what is the coefficient matrix? So this is our coefficient matrix. Okay, this is our coefficient matrix. And then the unknown matrices are dx, dy, and dz. So I will show you later how to construct those matrices. Let's compute D first. Okay. So, a determinant, so let's just write it down. So I won't go through the process of doing the diagonals again because we've already did that many times. So in the determinant videos. So you already know how to do that. So 1, 2, -3, -3, -5, 3, and then 4, 6, 4. Okay, so this is our coefficient matrix, right? So if we get the determinant of this, the determinant is actually equal to 4. Okay? So the determinant of this coefficient matrix right here is 4. Okay, so now let's find the matrices for um, the unknown matrices that we can find dx, dy, and dz. Okay, so for the unknown matrix for x, okay, how do we construct that? Let's copy this first. Okay, so what we're going to do actually, so this is the x column, right? So what we're going to do is we're going to substitute the constant column here into our x column. So what will this look like? This will look like 3, 6, 6, and then -3, -5, 3, and then 4, 6, 4. Okay, so if we get the determinant of this, so this is actually, determinant is actually, so let's just get this because this is already determinant. So the determinant is actually 42, okay, for this one. So what about for the y? So again, we are going to, so this is y, right? So we're going to substitute this again here. Okay, same goes for z. Okay, so 3, oh no, that's wrong. So we have here 1, 2, -3, and then we have 3, 6, 6, and then 4, 6, and 4. Okay, so if you find the determinant for that, it is actually equal to 30. Okay, now for the last one. Oh, sorry for that. So, again, so this is z, right? So we're going to substitute this here again. So what are we going to get? So 1, 2, -3, -3, -5, and 3. So 3, 6, 6. Okay, so dz is actually, so if you get the determinant again using the determinant method, finding determinant method for 3 by 3 matrix that we introduced in the previous video, we will get 15. Okay, so based on these, our results, so let's try to use the Cramer's formulas right here. So let's find x, okay? Let's find x. So x is equal to dx all over d. So what is our dx? Our dx is 42. 42 all over 4. So how can we simplify this? This is divided by 2, both numerator and denominator. We will get 21 all over 2. And our y is equal to dy over d. So what is our dy again? Our dy is 30. So 30 all over 4. So cancel out the 2, you will get 15 all over 2. Okay, so it's going pretty good. So dz over d, what is our dz is actually 15, right? 15 all over 4. So we cannot simplify that even further. Okay, so these are already our answers. Okay, so it is exactly the same as these answers right here. So it's very nice. Okay, so that is how you apply the Cramer's rule. Okay, very awesome indeed. So that is the last lesson for this. I mean the last video for this lesson. So I hope you learned a lot throughout this lesson, and yeah, I will see you in future modules.